Oh, so welcome back. So I initially a little bit of technical issue there. I'll just continue right away. So we are on this place. So the last instruction was to do what is called equal count stratified sampling. So we were able to nail that completely. I'll just go ahead and continue from there. So down a little bit. That was the last thing we did. You get the proportion from attrition EQ, that is equal stratified sampling. So let's look at weighted sampling, which is under stratified sampling. So we have to plot this together. Plot years at the company information as a histogram. So following the instruction. Since we need to reload the kernel or even reload the page, the home button isn't working yet. Let's reload the page. This should be working fine by now. Oh, voila. Working absolutely fine by now. Okay. And voila. So we need our results here. So plot here the company from attrition pop as a histogram with beans widths from 0 to 40, from 1 to 0 to 40. So for beam width of 1 from 0 to 40. Let's look at it here also. This is our histogram. So we're plotting the years at the company column from this our initial data set here that we have here. Years at company column. Can see this column. So that is what we visualize in this little histogram here. Oops. We're supposed to use the np dot range. Okay, np. Okay, let's use this method. We have similar results. Why not stressing me? So I'm getting the same result now. Let's see. Let's see. Yeah, exactly the same results. But this is using np dot range dot a range. Now sample 400 employees from attention population weighted by years at company. Okay. Some 400 employees weighted by years at company attrition weights. Let's solve that. Hold on a minute. Let's say sample 400. Sample 400. They didn't ask you to set random sets though. Let's see. What's this? What's the problem here? So I'm trying to sort. Come on. Let's see. So sample 400 employees, formattation position weighted by the years at company. Okay, we want to weight it by years at company. Let's see. Let's run the code and see. Yep, we nailed it. Let's see it in action here. Voila. You can see. So I have something 400 rows of data out of the population. Okay, now let's plot years at company formattation weight as a histogram with bins of 1 from 0 to 40. The similar thing we did earlier. For this time, I want to plot this. I want to plot this line of code. But we're definitely going to be plotting these attrition weights. Okay, here's our company following that same method. You can see now it's quite slower. It's quite slow comparing the result we have here. Let's see it in action here. Voila. We have almost similar results. different. Look at this right hand side. Look at it here. So which is higher, the mean years accompanying from attrition population or the mean years accompanying from attrition weight? Oh, so we can just get the line of code for that. Let's see. Ooh, can see sample mean years. Can see the sample mean years. So the one that is higher is the second one, attrition weights. Blue, the sample mean is higher. You see, marvelous means the weighted sample mean is around 11. You can see we figure that out here around 11.3. Why the which is higher than the population mean of around 7. The population mean is around 7, right? Look at it here. Interesting. So let's continue. Now let's do what is called cluster sampling. What is called cluster sampling. Let's take a quick break. Let's look at what is called cluster sampling in Python.
One problem with stratified sampling is that we need to collect data from every subgroup. In cases where collecting data is expensive, for example, when we have to physically travel to a location to collect it, it can make our analysis prohibitively expensive. There's a cheaper alternative called cluster sampling. The stratified sampling approach was to split the population into subgroups, then use simple random sampling on each of them. Cluster sampling means that we limit the number of subgroups in the analysis by picking a few of them with simple random sampling. We then perform simple random sampling on each subgroup as before. Let's return to the coffee dataset and look at the varieties of coffee. In this image, each bean represents the whole subgroup, rather than an individual coffee, and there are 28 of them. To extract unique varieties, we use the .unique method. This returns an array, so wrapping it in the list function creates a list of unique varieties. Let's suppose that it's expensive to work with all of the different varieties. Enter cluster sampling. The first stage of cluster sampling is to randomly cut down the number of varieties, and we do this by randomly selecting them. Here, we've used the random.sample function from the random package to get 3 varieties, specified using the argument k. The second stage of cluster sampling is to perform simple random sampling on each of the 3 varieties we randomly selected. We first filter the dataset for rows where the variety is one of the 3 selected using the .isin method. To ensure that the isin filtering removes levels with 0 rows, we apply the cat.removeUnused_categories method on the series of focus, which is variety here. If we exclude this method, we might receive an error when sampling by variety level. The pandas code is the same as for stratified sampling. Here, we've opted for equal count sampling, with 5 rows from each remaining variety. Here's the first few columns of the result. Notice that there are 15 rows, which we'd expect from sampling 5 rows from 3 varieties. Note that we had 2 stages in the cluster sampling. We randomly sampled the subgroups to include, then we randomly sampled rows from those subgroups. Cluster sampling is a special case of multi-stage sampling. It's possible to use more than 2 stages. A common example is national surveys, which can include several levels of administrative regions, like states, counties, cities, and neighborhoods. Time to sample some clusters.
Okay, let's get our hands dirty with cluster sampling. Oh, right here. I'm from Nigeria. How about you? Can you hear me? I'm gonna finding it hard to reply to chats. If you have an idea of where to do that. We're looking at what is called cluster sampling in Python. What is the benefit of clustering? It's taking time to load. I have no idea why. And let's see the benefit of cluster sampling. So cluster sampling is a two-stage sampling technique that is closely related to stratified sampling. First, you randomly sample which subgroups to include in the sample, then randomly sample rows within each subgroups. In which of the following situation would cluster sampling be preferable to stratified sampling? Okay, so let's pick an answer. The interest of is on ensuring each rare group will be represented in the sample selected. Cost is not a limitation, and time can be spent carefully sampling from each group in population. Collecting an overall sample requires a lot of travel from one group to another to collect sample within each group. Okay, that's definitely the answer. So, life decision making. The main benefit of cluster sampling over stratified sampling is that you can save time and money by not including every subgroup in your sample. Let's perform cluster sampling. So we have 3 more instructions to complete before this section ends. So it says, now that you know when to use cluster sampling, it is time to put it into action. In this exercise, you will explore the job role column of the attrition dataset. You can think of each job role as a subgroup of the whole population of employees. So create a list of unique job role values from attrition population and assign it to job roles population. Okay, that's quite simple. Okay, let's create a subgroup. Create a list of unique job role values. Let's do that. Randomly sample 4 job role values. That's going to be a list. That is attrition population. The job role column. Job role column. Dot unique. Since we want a unique list, they want to make it into a list. I'm going to say to lists. Now, in order to randomly sample, let me just check this out in my Jupyter notebook here. So I call on the job roles data frame. So these are the unique job role list that we have here. Unique job roles from our main data set here. The job roles column. Age. So I'm definitely looking for the job role column. That's quite funny. Aid attrition business delivery departments. Business delivery departments education. You know the job role column here. Why is not finding it as to come up with? Mm. So let's move on. What about job role population? Then it's randomly sample 4 job role values. Using cluster sampling, right? Okay, let's randomly sample that using the cluster method of sampling. That will now be job role sample. That will be random dot sample. When you sample the job roles pop, our k will now be 4. You can see we randomly sample 4 job roles. Oh, random dot sample is not defined. Oh. So I got that. Why is it not working in my own instance here? It's supposed to work here also. Let's say with another method, I can use to sample the 4 job roles. Oh, okay. The mistake that's happening is because this has not been imported in this instance here. Voila. That solved the issues there. You see, I didn't import this random, so this import random should be part of my libraries now. That is why I'm having that error there. So can we we've sampled 4 random jobs for this to work. Let's move to number 2. Then from here we could say job roles, random job roles. Then subset attention population for the sample job roles by filtering for roles where job role is in job roles.sample. Oh, interesting. So job roles condition, partition filtered. This is attention population. Job role is in job roles sample. So we call on this attention filter to get this result out. Let's on the line of code and voila. You see the 2 random sample that we've sampled. So we have our results here. So we actually filter for this. We randomly selected this research directorate, care, manufacturing director, and executive. Then we filter the whole condition to this. We have our new results based on that. Do you see the job role for those departments? We only have just 5 rows for that. Interesting. Let's submit and see. Voila, we need remove any unused categories from the job role. Remove any unused category from the job role. For each job role in the filter dataset, take a random sample of 10 rows, setting the C to 222. Okay. So remove categories with no rows. So we need to remove the category that have no rows from this job role filtered, attrition filtered that we have here. This attrition filtered. Then after that, dot cat remove unused categories to do that. Then we filter for this. Randomly sample 10 employees from each sample job role. What randomly sample 10 employees from each sample job role. to do that. So let's run the line of code. All I can see is a randomly selected employees. Oh, I'm going to use the go by method for this. Okay, let's see. When moving category, we want to use the go by. Citation filtered job role. So job role, cat remove or use columns. This is the same results though. You can see filtered job role dot cat. Okay, let's go with this. Similar results though. Oh, having error in this citation filter dot go by. What's with the error? Okay, let's submit and see. This is the last part. It's kind of tricky. We are getting there. Let's see. This randomly sample 10. Okay. It says for each row filter, pick random from this setting is 22. Okay, okay. Also go by job role. Oh, you have an error there. Oh, I didn't mention my filtered column. Dot go by. Let's on the line of code again. Well, I should have our result by now. Interesting. Ooh, mine should be equal to 10. It said filter 10 rows, not 5 rows. 10 rows, not 5 rows. Okay. Oh, my random state. Oh, come on. 2022, not 2021. Interesting. I made a couple of errors in my line of code there. Ah, voila, we nailed it. Let's recreate it here. We want to remove category with no rows. We've done that. Ooh, well, that should be correct. We have it. So these are random rows, you see. So it's saying randomly sample 10 employees from each sampled job role. So print the sample. So this is the sample cluster. Ooh, there is a lot of technique there to use there. So let's see the last lesson here that says comparing sampling methods. These sampling methods are quite unique and quite different. Just have to know which one to use based on what you want to do. Let's compare different sampling methods. That's a lot of sampling covered in an hour plus. Ooh, this is
Let's
too
review the various sampling techniques we learned about. For convenience, we'll stick to the 6 countries with the most coffee varieties that we used before. This corresponds to 880 rows and 8 columns, retrieved using the dot shape attribute. Simple random sampling uses dot sample with either n or frac set to determine how many rows to pseudo-randomly choose, given a seed value set with random state. The simple random sample returns 293 rows, because we specified frac as 1/3, and 1/3 of 880 is just over 293. Stratified sampling groups by the country subgroup before performing simple random sampling on each subgroup. Given each of these top countries have quite a few rows, stratifying produces the same number of rows as the simple random sample. In the cluster sample, we've used 2 out of 6 countries to roughly mimic frac equals 1/3 from the other sample types. Setting n equal to 1/6 of the total number of rows gives roughly equal sample sizes in each of the 2 subgroups. Using dot shape again, we see that this cluster sample has close to the same number of rows, 292 compared to 293 for the other sample types. Let's calculate a population parameter, the mean of the total cut points. When the population parameter is the mean of a field, it's often called the population mean. Remember that in real-life scenarios, we typically wouldn't know what the population mean is. Since we have it here though, we can use this value of 81.9 as a gold standard to measure against. Now we'll calculate the same value using each of the sampling techniques we've discussed. These are point estimates of the mean, often called sample means. The simple and stratified sample means are really close to the population mean. Cluster sampling isn't quite as close, but that's typical. Cluster sampling is designed to give us an answer that's almost as good while using less data. Here's a slightly more complicated calculation of the mean total cut points for each country. We group by country before calculating the mean to return 6 numbers. So how do the numbers from the simple random sample compare? The sample means are pretty close to the population means. The same is true of the sample means from the stratified technique. each sample mean is relatively close to the population mean. With cluster sampling, while the sample means are pretty close to the population means, the obvious limitation is that we only get values for the 2 countries that were included in the sample. If the mean cut points for each country is an important metric in our analysis, cluster sampling would be a bad idea. Let's calculate some summary statistics.
Okay, let's finalize this part of the lesson. And voila, I'll move to sampling distributions next. 3 kind of sampling. So you are going to compare the performance of point estimates using simple stratified and cluster sampling. Before doing that, you have to set up the samples. Okay, you use the relationship stratification column of the population dataset, which categorizes the employees' relationship with the company. It has 4 levels: low, medium, high, and very high. Let's do that. Perform simple random sampling attrition on national population to get 1/4 of the population, setting the state to 222. Oops. Okay. We want to perform a sampling on the 1/4 of the population. There's a lot of population there. The additional population. Dot sample. So the fraction of the population we want to sample on is 1/3. Then the random states. Random state should be equal to this figure here. So the code that should be correct. Ooh, this 75% on 1/4. What does 1/4 mean? 0.25, that is 50% of the 1/4. Okay. So my mistake is in this my condition here. 0.25%. Okay. Let's perform this same sampling here. So we call on the attrition dot shape. We should see what we have here. We have 300. You can see 300 rows of data and 31 columns. Perform certified sampling on a population to sample 1/4 of each relationship satisfaction group. Okay. Want to perform the same thing on that particular column. Let's see. Let's wait for the page to complete loading. Okay. Let's submit. Oh, incorrect submission. Yeah. Let's do it properly well now. Oh, this is like the first one we did there. Okay, now after certified sampling, perform certified sampling on the attention population. Got to use the attention population column. Group by, what are you grouping by here? Also go by this column. I want to sample 0.25% of the population. Then our seed should be 22 here. Okay, we nailed it. Uh-oh. What with the error there? Let's call on this attention stats. Dot shape. So we have the same similar rows of column and data. But why is this page going back and forth? This is what we need there. Let's copy that. Oh, the page is still loading. Come on. This is not fair. Okay. Now let's create. Oh, this is pretty long. Oh, create a list of unique values. Okay, let's see. We have a lot to do here. Want to create a list of unique values. So create a list of unique values from attention population relationship satisfaction column. Randomly, okay, that is first instruction. List of unique values. Satisfaction unique. I'll be using the unique list attention population unique list. Line of code. So relation satisfaction unique list. Randomly sample two unique satisfaction values. I randomly sample two unique lists from there. Be random dot sample satisfaction unique. The k will be set to 2. Then filter is satisfaction condition to this. That will be in the sample. Want to filter for relation satisfaction, that will be in these two sample unique lists. Then finally is to prep condition.prep. Oh, let's see the attention cluster prep. Maybe attention cluster prep. Okay. Attention cluster prep should have this line of code. Remove categories. Then finally, this last line of the code. Perform cluster sampling on the selected group, getting 0.25 of the population. Okay. Oh, okay. Oh, we know this. Let's create same scenario and see. Oh, I'm having this error. I'm having an error here, which is absolutely correct in this instance. Now we have the three samples set up. Let's calculate summing statistics. I'm having an error here though. Let's sum it again. So we know this. So we're not running into any error here. Okay, this is what we can do. So finally, let's calculate the sample comparing point estimates. Let's see. Okay, let's see. Let me get help on this one for my list here. If this is going to work. Let's see. We can see our results here. Okay, low, high, low, high. Okay. Total sample, value count in sample. Okay. Okay, we're on track. Let's finish this part of the code and be done with sampling methods in Python. I'm going to group attrition by relationships at the fraction level and calculate the mean of attrition for each level. Let's see. Mean attrition population. So I want to group it by that. Let's see. Voila. We have our results here. Next one is that. There are similar results here. 0.2, 206, 207, 0.149. Okay. There's a lot of calculation here. So calculate the same thing for simple random sample. Tell the proportion of employee attrition for each relationship satisfaction group. This time on the simple random sample attrition SRS. So interesting. Oh, we have similar results here. Okay. You can see we have our result also. And finally, calculate the proportion of employee attrition. Same thing for stratified sampling. Now we're using stratified sampling. The bed is just loading and loading. Let's be patient with it. And finally, the last one, consider relationship satisfaction. Calculate the proportion of employee attrition for each relationship satisfaction group, this time on the cluster sample. So we use different sampling to calculate the mean, different sample method. Let's see how this one is going to look like. Oh, voila. Oops. So near the different sample calculation method, you see. Superstorming statistics, the numbers are all fairly similar, with the notable exception that cluster sampling only gives results for the cluster included in the sample, which is high and very low, while the rest give results for low, medium, high, and very high. You see the sampling satisfaction there. There's a lot of information to consume. Oh. So we completed chapter 2. So we are moving to chapter 3 on the next live stream. So this is talking about sampling distribution. Let's test your sampling. In this chapter, you discover how to quantify the accuracy of sample statistics using relative errors and measure of variation in your estimate by generating sample distribution. Oh, that's a lot. So that being the live stream for today. Alright, so that being the live stream for this different sampling method in Python. As usual, I'll leave a link to all the files, the attrition data set in the YouTube description, so you can also practice your sampling techniques. I'll see you tomorrow on the next live stream.